Good morning, everybody, and afternoon as well, depending on whether you're in the UK or in Europe. Thank you very much for joining us around this lunchtime session. It's our first lunchtime session of 2021, and we'll be doing a few of these to concentrate on various APIs and technologies that HERE Maps provide. So today we're joined by Alex Asaki, who's Fleet Marketing Manager at HERE, and he will be showing off a demo of HERE's Tour Planning API. So here's Waypoint Sequence Optimization tool for creating optimum routes for a single vehicle. It's one of the most popular solutions that we sell to partners and has made it into very many applications and services. So we're looking forward to very much what customers are going to do with this tour planning piece for making vehicles for multiple vehicles. So as we go through the demo, the presentation, please, it's a live session. We'd love to hear your input. Just press the chat button and type any questions you have, and we will certainly get to those at the end for the Q&A. So yeah, without any further ado, I will just hand over now to Alex with the presentation. Thanks, Alex.
Yeah, thank you. So as I said, and I think I will probably turn this back over to you in a moment here to explain a bit more about this. But yeah, my name is Alex Osaki. I'm the TNL fleet manager. So that's inclusive of kind of this tour planning API and the enablers that are built on top of it. And what I will do is walk you through sort of the context for that, a little bit about what we're solving, how we're solving it, and then go through a demo that kind of takes the material and then shows sort of what it looks like. It's a headless API, but the demo, there's a light UX around it, so I can kind of explain what's going on and then answer any questions that people have.
Fantastic. Yeah, and we'll pick up on the licensing piece at the end of the call as well and go through the various options for integrating this into your partner solutions. As the distributor for HERE Maps, Grey Matter is here to help you as a partner, to support you with your interesting products, onboard you onto the services, and support you right up to releasing solutions and adding various functionalities. So yeah, we'll pick up a little bit after Alex's demo on that one. So yeah, back over to you, Alex. Thank you.
All right, thank you. So when we're talking about tour planning, sort of the question that I want to begin with is just to clarify where this, like what the problem space is from a market point of view. It's something that I started, writing this up last year when things looked, earlier last year when things looked a little bit different. But I think over the course of that year, we've seen what initially started as sort of a hypothetical question about what customer demands were or what customer expectations were really sharpening into something critical. So when we first launched this product, we kind of said in a vacuum, customer demands are really increasing. Customers will say 55% of customers say that they will switch, they will switch to a delivery provider or to a retailer who has better on-time performance. 90% of customers say that the delivery performance will impact their decisions. So a missed delivery or a late delivery is something that they take into account when choosing whether to shop at a retailer again. And over the course of the year, we've seen, already in a decade where we had double-digit year-on-year growth in terms of same day or next day deliveries, we have seen a vast increase in the requirements for online fulfillment. And that's occurred against the backdrop of a cityscape that is changing, that's becoming more complex. We're seeing the need to manage traffic become more critical, and you see, I think, cities even in the context of the pandemic, using that opportunity to change how goods and services move through the city, making them more pedestrian accessible, changing kind of traffic flow restrictions. That means that having real-time accurate information to manage that is incredibly critical. And we're aware of this as a key challenge, right? It's retailers highlight last mile as a problem. We know that last mile is anywhere between 35 and 50, over 50% of the cost of delivery, and customer willingness to pay lags the actual cost of delivery, which means that retailers are subsidizing that cost, and it means that this is already a low margin market, and they are under constant pressure to compete, to meet customer demands, and to take advantage of new opportunities. Same day delivery services, on demand delivery services, things like that. So the question becomes, how do we enable that? Here has a couple of ways to do that. We talk about last mile as well. This is the kind of general problem space, but last mile is an all-in-one solution. So it includes a driver application and a web application. And it's built, the kind of API side of that is the tour planning API. So this is the vehicle routing problem solver, and it is designed as a way to optimize routes across a number of vehicles and jobs in a fleet. So when we talk about this, formally, it is solving the capacitated vehicle routing problem, which is effectively a traveling salesman problem that's being solved across multiple vehicles in a fleet. So we take into account the vehicle type, so the routing profile. We take into account capacity, as well as additional attributes. So if you say that a shipment needs to be refrigerated, for example, that's then built into the job description and then linked against vehicles that have those abilities. So the result of the tour planning API is a set of optimized tours, so a set of route plans, job lists for each driver in a shift in a fleet. And those can have any number of configurations. I'll talk about that a little bit more later. But basically, you have a spreadsheet, you have a CSV file with a bunch of different jobs that you need to get done today. And you have what your fleet looks like. What you want out of that is, how do I solve those jobs? And we target a number of different use cases for that. One of them is kind of on this operational side. We are talking about on-demand services. I need to find suitable drivers and create routes throughout the day. One of them is this, once things have been calculated, once I need to adjust those tours later, how do I handle that? Well, you can feed the tour planning solution back into the tour planning solver to update that solution. And then this broad, category of multi-vehicle planning. So kind of dynamic route optimization for multiple vehicles based on their capacity, based on any special equipment, based on job priority and time windows. All of that coming back to produce a useful solution. That's true from the operational side, but also from the planning side, that means being able to optimize forecasts better. It means reducing the number of vehicles that are required to serve the daily jobs, because the vehicles can be used more optimally. So this is really what we're talking about solving. And again, formally speaking, there is a front end that comes from here last mile. It is the tour planning API itself is the top right corner of that. So it's a multi-vehicle routing optimization focused on solving a traveling salesman problem across multiple vehicles in a fleet, based off of here platform data. So the road geometries, the attributes, real-time traffic, predictive traffic. So the goal is to produce a highly accurate, reliable tour planning system. Just because this question comes up often, I would note that it is a globally available product. What changes based on region is what aspects of it are available. Are we talking about, what kind of traffic data do we have? Do we have special truck routing profiles? But it's generally a globally available product, which is, I think, important or useful when we're talking about the use cases, and we're talking about who really we can offer this to, or how we can help them. And that's basically it for the groundwork. So what I'd like to do is kind of walk through a product demo and talk through how this is actually dimensioned in real life. So the tour planning API, as I said, is a headless API. So what we've done here is we've set up a map that shows a number of deliveries that need to be managed, with the aim of demonstrating how. Sorry, I lost my mouse. Demonstrating how we would make these deliveries. What the data actually looks like can depend. Fundamentally, what we are putting into the API is going to be a JSON file that is going to look something like this. So what you'll see is you will have a number of jobs, and those jobs have times and places, and they can have additional parameters attached to them. So again, if you need to attach a skill to it, so if you say I need this to be carried by a refrigerated vehicle, you can put that in as well. Jobs can be either pickups, so this is I'm collecting things and returning them to a depot. They can be deliveries, i.e. I'm taking things from a depot to an end destination, or they can be sequences of pickups and deliveries. So you can imagine the scenario where you would need to pick up an item. Say if you were doing an on-demand delivery kind of thing, you're picking something up from a restaurant, say, and delivering that to an end customer, or a customer. Those would need to be handled in sequence. There can be any number of them, so you can have multiple pickups attached to one delivery, and the problem solver assumes that all pickups need to be solved for the delivery to take place. So you have a set of these jobs. These jobs can have, additional metadata you also want attached to them, and then this dimensionless demand quantity. So you can think about this. This is, as I said, is kind of a dimensionless number. So you can think about this as package size. You can think about it as package volume, depending on kind of what you're managing. The demand, so required skills and required demand are matched against the capacity and the skills of the vehicles. So you have this job list, and then I'm going to scroll to the bottom of this JSON file here. You have the fleet configuration. And that fleet configuration is going to tell you, these are the vehicles I have. In this case, we just give them a unique ID. We give them a profile, and then we attach user-defined cost variables. So based on distance, based on time, and then the shifts that they're available from, and implicitly the depots that they are being stored at. So a tour can have a different endpoint and start point. It can have the same endpoint and start point. It can kind of wind up being effectively open-ended, but all of that is stored as part of the problem file. So this includes the profiles about the fleet and the depot where they're being stored. That's then used as input for the tour plan, which again is returned as, in this case is returned via JSON, where for each tour, you have the vehicle that it's been assigned to, and then all of the stops on that tour. And that is, in this case, the problem file is all deliveries. So there's not any kind of complication here about matching pickups and deliveries. But what you see is this sequence of, for this tour consists of 12 stops or 13 stops served by one vehicle. So that's what it looks like. What you do with this information is kind of up to you. This can be something where you can just extract that, put that in a PDF, print it out, and give it to the driver. Say, here's your run sheet. Go make these deliveries. Or you can extend that, turn that into a waypoint sequence where you see all of the stops in order. It sort of depends. We're pretty agnostic about that. But that's the output of it. So it's fairly simple. You have just a list of jobs, and what you get out of that is a list of tours. So the synthesis of that. So if we look at what this looks like, we have here a set of a number of parcels that we are wanting to deliver here in Berlin, which is where I live. We can see that traffic is incorporated as part of the calculation. So predictive traffic is used if we're talking beyond a certain time window in advance. But we are talking about using historical, live, or predictive traffic, basically, in order to calculate the data that comes back from this. We have the fleet configuration. So my fleet consists of 10 vehicles. Each of them can carry 15 parcels. So again, this is this dimensionless demand figure. And then what we can do is just say, plan tour, and what we get back from the API should be a set of the tours that are attached to each of these vehicles. So what this is telling us, and this I think probably at the basic case should have been sort of obvious, is that for a sufficiently long period of time, if we have 60 parcels and we have 4 vehicles that can each carry 15 parcels, we only need 4 vehicles out of the fleet to solve for all of these. And what we get from that is we can see this is what the tours, this is what the stops on this tour looks like. We can see for each of these tours what the estimated completion time, what the estimated cost based on the kind of cost factors that were built in are, how many stops are involved here. But as we have this ability to recalculate that, to kind of see what the impact of changes are on the tour, we could say, for example, what happens if I am talking about what happens if I'm not talking about a full day tour? What happens if I'm talking about a much shorter shift? In that case, we can run this again and see how many vehicles would we need to complete this? Actually, is it possible for us to complete this? In this case, yes. So it looks like we can actually do this with the same number of vehicles. So let's try that again. So let's see. So the average tours here come up to being about 2.5 hours. So let's compress our shift times further if we can. Yeah. Let's say that we want to do this faster than we can with any one vehicle. How many will it take in this case? Again, is this possible for us to do? And in this case, yes. So if we say that we want to serve all of these within a 2-hour window, and you can imagine a business scenario where you would want to do that, right? You can imagine a case where you want to be able to offer narrow delivery windows, or you want to be able to where your shifts are quite condensed. What we can do is say, yeah, if you wanted to serve all of these in 2 hours instead of 2.5 to 3 hours, you would need 2 more vehicles in the fleet, and you can kind of compare the costs for that. So this is an area of where we can use the ability to kind of model what things look like, again based on real-time conditions. We can use that to make informed decisions about how the fleet should be configured, or what the capacity that can be solved from that is. And you can also imagine that if we keep the same time parameters, what happens if our depot is located further away? Perhaps this is where we can kind of balance out this. Here again, if the depot is further away, maybe this is something where the real estate is cheaper out there, but that means that we either can make fewer deliveries, those deliveries take longer, or more vehicles are needed in order to make them. So this is again a case where we can use the tour planning problem, the capacitated vehicle routing problem, to make decisions about how we want to structure these tours. And we can see here the difference in load factor between the different vehicles. So it's a very simple API fundamentally. It's a powerful API because it's doing a lot of different, it's integrating a lot of different variables under the hood, but it is fairly simple. I have 60 jobs that I need to get done in this case. I have 10 vehicles available to solve them. How many of those vehicles do I need? How quickly can I get it done? How much do I expect it will cost? And you can imagine as you connect other pieces to this, as you kind of take this from, this is the kind of the kind of theoretical tour, to say, okay, well, this is actually the stop sequence that I would expect to see. This is what these waypoints should look like. You can imagine then doing an analysis afterwards. How closely did the actual delivery track to what we expected it would look like? How quickly did how closely did our estimates of the job completion time track to how long it actually took? So by using a solution like this, you have the ability to answer those questions in a more formal way, and in a way that's more grounded in real time, real world information. So tour planning we really see as an enabler for a number of different scenarios, not just these kind of end-to-end last mile routing services for retailers or for kind of e-commerce companies, but just as of ways of kind of solving more complex problems about fleet utilization or fleet deployment in an accurate and reliable way. But as I said, it's fairly straightforward in terms of what information goes in and what information comes out. So what I would say is that's basically that is basically the demo. And if there are questions, I'm happy to help with those.
Thank you very much, Alex. That was a wonderful presentation. Very interesting. It's really good to see how that will be used, and I'm sure our customers will come up with lots of interesting ways of actually utilizing that in the real world. So yeah, I was just having a look at that. If I have a mixed fleet, maybe some trucks, some vans, maybe some electric vehicles, I take it that's fully supported, and I can just build up a single tour.
Yes, yeah. So the vehicles can be, when you create the problem. So this is part of the JSON file. All of the vehicles have or can have separate profiles. That's used both to define the routing. So we would handle trucks differently than vans, as well as the capacity, as well as any additional vehicle capabilities. So again, if the vehicle has a refrigeration unit, if the vehicle is an armored car or something like that, and you need high value goods need to travel in a particular way, those can all be made part of the problem. You can just identify this is the vehicle type, and then that's used. You can also define the vehicle cost, or like what you expect its utilization cost to be like. All of that can be done as part of the JSON file.
Perfect. Yeah, that's great. No, so I had another question around the cost. So obviously this is I was wondering if this is fuel costs, or does it include labor? I guess, as you said there, the customer can define that themselves. So
yeah, that's defined by the customer. So it becomes part of the problem. You can define there's kind of a fixed cost, or there could be like a fixed hourly cost, or there could be a cost per mile or per period of time. So that's something where, obviously here has services that can provide kind of estimated carbon cost, or estimated, you can extrapolate from the distance, or from the, extrapolate from the distance what you would expect the cost in fuel to be. But that's something where a fleet manager can also specify those themselves.
Fantastic. Yeah, I can imagine. So it's powerful, and customers can define it themselves. Another question, is there support for electric vehicles, and can you specify a charge range in the vehicle attributes?
Electric vehicle routing is supported. Yeah, electric vehicle routing is supported within the HERE platform. To be honest, I would need to follow up as to how that's exposed in the tour planning API. Tour planning it wraps other HERE routing services, which do support it, but I will admit I don't know whether there's a specific profile defined for EVs.
Perfect. Yeah, just thinking about the future, right, Alex? I've got a question here in the chat. So, in addition to vehicles, can you assign drivers that are subject to some constraints to tours as well?
Yes, so that's it's basically kind of handled in the same way. So yes, driver shifts and capabilities also become part of the problem definition. So if those need to be kind of allocated separately from vehicles, then that also can be handled there.
Perfect. And does that include sort of break times, or any breaks that they have to do by law as well? Can you set that?
Yeah, you can define the that would come as part of the shift time definition. In general, I would say that we are often talking, and you could kind of see that in the scenario that I walked through, is that we're generally talking about urban deliveries that tend to take place over slightly shorter periods. So it's a little bit less the kind of like it's a little bit less the kind of, you know, particularly like the middle mile problem where you're talking about you know, compliance issues around around like long haul drivers, and more, yeah, a lot of the shifts that we're talking about are, yeah, maybe in the 3 to 4 hours.
Perfect, thank you. So you mentioned that once you output the tour, there's a lot of flexibility around what customers can do. So they may want to just print these off, hand them to the driver, but I'm thinking also maybe they can export those routes to a navigation device. Is that straightforward to do with the Here Mobile SDK? And how do they do that? Just pass those routes across?
Yeah, exactly. So what the route comes, so the route definition is a set of stops. Those stops have a latlon attached to them. So it's pretty simple to just pass those to the here to here routing. They then become waypoints, and what you get back from that is a route that is a series of waypoints. The other way to do that, which we used, for example, in Here We Go Deliver, which was our kind of small business focused tour planning for COVID last year, was that you get the run sheet back, and then each stop on the run sheet is a separate leg. So then that the run sheet itself, if you open that link, it opens it in your navigation app. In Here We Go, in this case, with routes to the next point, to the next part of that journey. So it kind of depends on how you want to handle that. My feeling is probably that that's a more logical or straightforward way to handle it, just because getting back like one route with all of the waypoints attached, well, all the waypoints as part of it, you see that if we look back at the map, that's basically what's happening here. Is you have one route that has been calculated, and you kind of see it matched against the roads. That is a set of waypoints. But from a navigation point of view, I would kind of expect that in most scenarios, you would want to be spending more time at a stop. You would want to be collecting proof of delivery. You would want to be performing some activity for which it might be easier. It might be just easier, or more like from a UX point of view, it might be nicer to break them into separate segments, separate components.
I think so. Yeah, that's what I had in mind as well. If you need to do the proof of delivery, maybe there's some geofencing in the background when you've arrived, and there's other parts. Yeah, that makes sense. Obviously, the longer routes, a bit harder to manage. Question in the chat from Jan here. Says, great presentation. Is there anything from Grey Matter or here that has a pre-built interface like the one in your demo, or do customers have to build them themselves?
So from an end-to-end, from like a product end-to-end capability, this is basically what the Here Last Mile application is for. That kind of simplifies the UI of defining your depot location, defining your fleet configuration, defining your drivers and the shifts, importing the jobs, as well as then the process of dispatching the jobs and navigating to them from the driver side. So that's sort of what it that's sort of the easy answer to that, is that the closer you get towards, and the closer you get towards talking about a full application, like adding more UI to it, the closer you're really getting to something like Here Last Mile, at least from the Here side.
Perfect. Yeah. So you could use the code examples and then build something up. We've had another partner that's built their own UI around tour planning, but hopefully some of the ideas you've seen in the demo will give you a good start as to making your own UI for this. So I think that's covered the questions that I had and the ones in the chat. So we have a minute left, so I'll just open the mic up. Does anybody else have any questions for Alex? I think potentially the silence there is saying, Alex, thank you. That was a great presentation and you've covered everything. And they're going to go off now and commence with development.
So, Sean, not one specifically for Alex, but one from Sam there. How do customers get started with testing this?
Perfect. Yeah, so that's a very good question. So if you're looking to start with this API, Grey Matter will provide you with a test account and will also provide full technical support. So you don't just have to go onto web forums. You can make use of our expertise, and we can involve here to help answer any questions. But the customers we've had are fairly self-sufficient. But yeah, if you just contact Grey Matter, so Alex, if you want to just push it over to our contact slide, please, should be the next slide in the deck. Perfect. If you have an account manager already with Grey Matter, please reach out to them and they will arrange this for you. Or you can just contact us here at greymatter.com or give us a call. We'll contact you after the webinar to discuss your use case for the API and how we can support. But yeah, we can provide a fully supported evaluation trial. We've already had a few customers, as I say, who have done this already and are getting close to bringing it to market. And also, if you speak to us, we can advise you on what other complementary technologies here has. There's lots of other stuff in the fleet management product stack that can easily complement the tour planner. I mentioned the navigation. Alex touched upon there some of the post-trip analysis if you want to take the tours and analyze them post-event as well. So you can do the full scheduling, monitoring and post-trip analysis piece. So there's lots more to it. So yeah, let's have a chat and let's pick that up after the call. And also please stay tuned to our newsletters and website for future HereMap developer events that we will be running in the future. So yeah, so if there are no more questions, just want to thank Alex again, and for everybody for attending today. Enjoy the rest of your day.